Hello, my name is Amy Chu, and this is my final project video for Introduction to Material Science. In this video, we'll be covering one of the most important concepts I believe we went over in class, and this is diffusion. We'll cover what diffusion is, the different kinds of diffusion, and why it's such an important concept in engineering, specifically chemical engineering, and just in our everyday lives. So we'll go ahead and start with what is diffusion. So diffusion is the natural movement of atoms up or down a concentration gradient. This happens naturally just because atoms are in constant thermal movement because of the energy they hold inside them, and this allows them to move and relocate to create more balance and concentration. This also is dependent on two things: whether or not the atom has an empty adjacent site, and whether or not it has enough vibrational energy within itself to create lattice distortion and break the bonds it has with the atoms surrounding it. Some of the kinds of diffusion we'll be discussing will be interdiffusion, self-diffusion, interstitial diffusion, and vacancy diffusion. So we'll go ahead and elaborate on each of these concepts by using 3D models, which will be shown ahead. So the first one we'll be discussing is interdiffusion. These happens when atoms travel from an area of high concentration to an area of low concentration. So as we can observe in this video, these little balls with the holes in them can represent our solute, and then these is our solution. So obviously the solute has a higher concentration, so we want to create a balance, and the atoms will move to create this balance by transferring to the area of lower concentration. So as we can see, this is balancing out, and now just the atoms keeps moving this way. That is interdiffusion, and it happens in alloys. The next one we'll be discussing is self-diffusion, and this is the natural migration in elemental solids of atoms, just because since atoms are constantly moving around, if they have an empty adjacent side and the sufficient vibrational energy, they will interchange places with each other. And then two kinds of metallic diffusions we mentioned is vacancy and interstitial. So vacancy happens when atoms exchange with vacant spaces. So it is dependent on the number of vacancies around it and activation energy. So as we can see here, we're going to start with this one. So this one represents the first atom we're going to focus on. Since it has a vacant space adjacent, then naturally it will move around here, and now we have this empty space. So the second atom will move around to the vacant space. They both have enough vibrational energy to produce this, and now we have this empty space. So any of these would be able to move and cover it, and then the process will keep going on and on. And then the last one we'll be discussing is interstitial diffusion, which happens with smaller atoms such as carbon, hydrogen, oxygen, and nitrogen. It is more rapid than vacant diffusion, and what we can see here is these two atoms, which are a little different, so it's easier to make them stand out because they're also smaller than the rest. Will be able to move between these atoms. So we can see here, this one moved to here, and then this one moved to here. So this is what happens in interstitial diffusion. So these are the four kinds of diffusion, and now we will cover why diffusion is such an important concept. So within engineering, especially in this class, which is material science, we talked about defects in substances. These defects are responsible for the physical properties of the materials, and it's the whole reason we're studying material science, to decide which defect or which physical property is desirable or undesirable, especially when deciding for projects or within industry. We need to know what each physical property and defect will represent once we're working with it. The other reason is just it's such a basic concept, even for simple biology. This is the way atoms exchange substances within the cells. So substances that the cell needs and are outside the cell are in a higher concentration, and they will diffuse into the cell, which has a lower concentration, and this way the cell will be able to get the sufficient substances and nutrients it needs for survival. More specifically, within chemical engineering, diffusion is also a determinant for the rate of reaction, and this rates of reaction will control our chemical engineering processes and will then be the reason we are successful or unsuccessful within the production rates, and this will also affect the cost of production. And as chemical engineers, we want to try and bring down that cost, so being able to manipulate or understand how the diffusion and these different substances work is going to be extremely helpful. Some of these examples within engineering can be case hardening, so we diffuse certain atoms to the top of a material to make it harder and more durable. We can also observe it in semiconductors, which use doping and just for the general processing of glasses, ceramics, and metals. So these are some of the examples of why diffusion is so important, and I hope this video was helpful to understand diffusion and its importance. Thank you.